Welcome everyone to Minimal APIs with ASP.NET 6. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. But the cool part about this talk is there are no slides. We are going to live code everything. We're going to look at upgrading an ASP.NET app from .NET 5 to .NET 6, and we're going to leverage minimal APIs together with the other paradigms, MVC, WebAPI, and Razor Pages. So let's go look at the code that we're going to look at today. If we head off to robrich.org, we can click on presentations, and here's minimal APIs with .NET 6. The code is up on GitHub right now. Let me paste it in chat as well. So we've got the code, and each of the steps in our presentation will be walking through each of these folders using the next feature of .NET 6. And so let's dig in. We have here a folder that just has a site.cs proj. Let's open this up in code. And the CS proj is pretty empty. It basically just says this is .NET 6. I have turned on a few other things though, like implicit usings and nullable reference types. Now let's create a new file. We're going to say new file. Oh, apparently I just also upgraded VS Code. Excellent. New file. I'm going to call this program.cs. And then let's say var builder equals web application dot create builder args. If there are any args coming from the command line, var app equals builder dot build app dot run. And now let's map one URL. Let's say app.mapget, and we'll map the / to this thing that returns a new object. And let's say message equals, and I'll interpolate this. Let's say hello world. But instead of saying world, let's actually say hello name. Now I need to take in names, so let's take in string name into this lambda. And I'm even going to say, I'll give it a default. If you don't pass one in, then I'll do world. Ooh, yes, I would like to add some stuff. VS Code added this .vs code folder that allows us to run some debugging here in VS Code. We won't use that part today. And further, I'm going to say this is from the query string as opposed to other places. Here's the using statement. Thank you. And now let's run this. .NET run. Now the really cool part about this is that in just a few lines of code, we're able to build up this web server. Now this doesn't look like anything that we've done in .NET before, but once this finishes building and running, we'll see that this is a full-fledged web server. So let's head over to HTTPS localhost 5001, and we get hello world. Excellent. If we were to pass in name equals Philly, now it says hello Philly, Philly.net. And what's excellent about this, we have HTTPS. If we take a look at the query, we can see that not only is it doing the things, but in the response, it's actually giving back the correct application JSON content type. Everything is working the way we expect. And we did all this in 5 lines of code, including a using statement. That's pretty cool. So let's stop this web server, and that's where we're going to go. Let's back up a little bit and start with a .NET 5 app and see how we can get there. So that was step 0, where we built a bare minimum API. Let's take a look at step 1, our ASP.NET app. Now we know this is an ASP.NET 5 app because here in the project.json, we are in the CS proj rather, it says .NET 5. Now we want to upgrade this from .NET 5 to .NET 6. So let's change this from 5 to 6. Now we're going to see a lot more things of upgrading to .NET 6 and the various features in C#10. But just in doing that, you'll get some performance gains because under the hood, it's going to use span of t instead of the old way. So that's pretty cool. If you only want to upgrade from 5 to 6 there, that'll definitely get you some benefit. Now, I'm not sure if we have any updated Nuget packages, so let's come here and we'll manage Nuget packages and see if we have any updates. Ooh, it looks like we do have an update. So let's upgrade this Nuget package and away we go. Now this project is now running .NET 6. Now what's cool in this project is I have MVC, Razor Pages, and WebAPI. And I chose to put all three in place, not that we would, but to show that they aren't mutually exclusive technologies. When I create a file new project, either in Visual Studio or in the .NET CLI, then I get the chosen piece, but they aren't mutually exclusive with other pieces. So we've got our website going, and we can see that it has all of the pieces here of lots of different types of solutions, lots of types of projects here. So let's pop open this project. Here we go. And now different pieces are different parts of the system. So we have some MVC parts, we have some Razor Pages parts, and we have some WebAPI parts. First up, this home controller is an MVC thing. So we'll come in here, here's our home controller, and our home controller will do what controllers do, pass that off to a view. Here's our view, and we have the home view, and we can see that content in place. It's no longer a .NET 5 project, it's now a .NET 6 project. That's cool. So that is our home page. When we're looking at our About page actually doesn't use MVC. Our About page uses Razor Pages. Now Razor Pages is good if I have relatively static. Back in. Yeah, Teams is really good. Are you able to hear me better now? Okay, so we execute it and we can see that here's the curl command that we would need to do it, and we have some output here from our web API. Now this is cool. Upgrading from .NET 5 to .NET 6 didn't change anything about any of these technologies. Web API, MVC, and Razor Pages all work well together.
You're out again.
Team, that's not fun. If this doesn't work, I'm going to switch microphones and we'll see if that other microphone works better. So we've got Web API with our MVC with our controllers, and then we have here down in our configure services map endpoints, map controllers. For Razor Pages, we have this part where we add Razor Pages and we map Razor Pages. For Web API, they're just controllers, and so when we mapped controllers, we mapped the controllers here, and we also added Swagger in interesting ways. We also only added the Swagger UI in development to avoid leaking those details into production if that's not what we expect. So upgrading from .NET 5 to .NET 6 in all three of these paradigms work just fine. And new in .NET 6 is minimal APIs, a fourth paradigm, and they all work well. They all work really well together. Okay, so we've upgraded to .NET 6. All three of our paradigms work just fine. And now let's play with some new features in C#10. Look at file scope namespaces, global using directives, automatic global usings, top level statements, async main, minimal APIs, parameter and dependency injection, and integration testing. So let's get started. The first thing that we're going to do is file scope namespaces. Now, as we look at this file, everything is inside this site controllers namespace. And we indent 4 spaces just to say we're inside the namespace. Our method indents another 4 spaces, and then our content in the method indents. So we're 12 spaces in without even saying anything yet. New in C#10, we can create one namespace that applies to the entire file. Now this is optional. We can definitely still do it the old way. But now we've done one less set of indents to be able to get this content in place. That's great. Now, if our CS file includes more than one namespace, then we can do it the old way, and that works great. But if all of our file is the same namespace, then we can use this syntax. And we can use it in some places, but not others. So let's upgrade this one to the new way. Let's upgrade. There we go. We've got a CS file here. Let's upgrade this. And got that. Let's grab this C# file. And we'll use that namespace. Excellent. We'll do this one and upgrade that to the C#10 file namespaces. We've got this one. And I believe we have one more here in the model. Excellent. And this then, let's go find all for namespace and see if we got them all. Yes, we did. Very nice. And so if we were to build and run this, let's save our solution file. Yes. If we were to build and run this, then it would build into exactly the same system that we had before. That's perfect. Now, if we have a file that includes more than one namespace, we can definitely do it the old way. But this makes the assumption that everything inside this file is in the same namespace. Next, let's take a look at global usings. Now, we have a lot of these using things at the top of every file, and we end up spending a lot of time deleting unused things and replacing them with other things, and then we use something and we put it back. And so let's see if we can use global usings. I'm going to create a new file. Let's create a new file here. I'm going to add a class. Now, and there's no real convention here, so I'll just call this one global.cs. And now let's put all of those using statements in here. No class definition, but let's change it to be global using. Now, by saying global using, then that will apply to every file in our project. Now, we don't need to put it in a separate file. There's no specific file name that we could do this. We could put it inside of startup.cs, but we do need that global word in front of it. So let's do it here, and we'll go like this. Nope. Nope. What is the magic key combination? That's not it. I thought it was that. Nope. We'll do it here, and here, and here. And now we have all of these things that we don't need to include these usings anywhere else. So let's go grab some more usings. I suspect that we can delete a lot of these ones, but let's come. Oh, yep, all of those are obsolete now. They're all gray. Let's take a look at the usings here. We've already got system. Excellent. Here in about, we might have a few more usings. Let's grab those and set them in place. I'll just set them into global.cs right now. We'll look inside program. Let's see what usings we have there. Here's some more. And we'll set them inside global.cs. Here inside startup, let's go grab the usings out of here. Cut all of those and put them inside of global. And in weather forecast, arguably this should be in the models folder, but we'll just leave it where it is and put that here. And then I will replace the beginning with global space, and let's do that everywhere. Now I have global in some places, so let's remove global and only have one global. And I love the green squiggles that tell me when I have duplicates here. So let's remove some duplicates. And now all of the pieces, all of the using statements throughout our entire application are here. That is perfect. Now we probably also need a global using site.models and global using site.controllers. And maybe site.pages. Oh, we already had models up here. Okay, so let's go find all of the using in our application, make sure that we collected them all. Yep, it looks like we did. Very nice. Now there's a few in our CSHTML files. Not quite sure how to collect those, but that was really cool. All of the usings from all of our different places are now in one file so that we don't need to specify these as we start up every new file. That's really cool. Now, one of the things that's really interesting here in the CS proj is that we can add another feature here that says implicit usings. Now I'm going to say enable, and now it's going to go look inside this SDK for all of the usings that have been exposed to us in a similar way. So let's build this again, and as we build this project, all of the usings from the SDK will be automatically built and injected into our site. So let's come here into our project. We've been upgrading this .NET5 project, and we'll come here into the debug folder into .NET 6, and we will take a look at globalUsings.g.cs. These are all of the using statements that get automatically injected into our project when we turn on that option. Now, we definitely could leave it off if we wanted to, but I'm going to copy all of these into the top of my file, and now it's going to highlight all of the duplicates. So I'll just go remove all of these duplicates here in green, and we'll be left with only the unique ones for this application. Great. I was able to shorten the list of usings to only those that are unique to my application. And all of the things that are assumed to be installed in every project are automatically pulled in. That's really cool. Implicit usings are awesome. Next up, we have this program.cs. Now, what we saw in our previous example was a much more compact program.cs. Let's see if we can upgrade this project to do that. So instead of create host builder, I want to get rid of this. Instead, I'm going to say this. var builder equals web application dot create builder, and I'll take in the args, and then let's configure services here, and then I'll say var app equals builder dot build, and I'll configure pipeline here, and then let's say app dot run. Now that obsoletes this method completely, and if we want to upgrade a little bit farther, we can just remove all of this content and it will automatically assume that this is a static void main inside the class called program. Now it gets this because it's program.cs here, and so now we've got that startup. Now a lot of the content is defined here in our startup.cs, and we could definitely do something like this where we can say startup equals new startup, and then in configure services we could say startup.configure services and pass in builder dot services. And then to configure the pipeline, we could say startup.configure, passing in the environment variable, so startup.environment. Startup dot, oh, it hasn't figured out what the namespace for startup is. So I could definitely do that, and that would work just fine. But let's optimize this a little bit more. Oh, configure. Rather than calling into there, let's go pull these pieces out of this. So let's go grab the configure services piece, and we'll set that right here in the configure services section. Now, we don't have services created straight away. We could definitely say var services equals builder.services, or taking that a step farther, we could just say builder.services. Services, there we go. So we've got builder.services here. Let's do that here. Let's do that here. And now we've done all of our configure method. Similarly, let's come here into our configure the pipeline method and go grab all of those details and set that in place here in program.cs. Now we have our app. We built our app here in builder.build, but we don't have environment. So let's say app.environment. There we go. And now instead of using endpoints, we could just directly use the app to do this. That's a great shortcut. And we can get rid of this. And now we're using the new startup syntax. Now, if we like the separation between program and startup, we can definitely use the old one, or we could inject things in interesting ways. But I kind of like this. This is a lot more compact. This is the startup experience. Now, maybe this is getting a little bit big, so we might want to shorten this a smidge or move this off to extension methods, and we could definitely do that to keep the majority of the explanation here, but the actual implementation in other places. Okay, so now that we've got the new builder in place, let's do some other interesting things. Let's, for example, dig into minimal APIs. Now, minimal APIs are really cool. Like MVC and WebAPI and Razor Pages, minimal APIs allow us to build really interesting experiences. Now, it doesn't obsolete any of the other three, and it isn't the magic bullet, so we're not going to convert everything into minimal APIs, but it is a really fun experience. We said map get previously, and we mapped the slash, but that's mapped to our home controller right now. So let's say API/minimal. And I want this to go to new object. I'm going to say message equals, and we saw this before, hello name or world. So we'll take in a string name, and let's annotate that as from query. We could let it automatically figure out where it's from. Maybe it's from the body, maybe it's from headers, but I kind of like decorating specifically to explain where it came from. And so now we've got that view word wrap. I bet word wrap is off in the tools options. So let's go see if we can turn on word wrap real fast. Word wrap. General, enable word wrap, please. Excellent. Okay, so we did a map get. We can also do map post. Now here I'm going to say /API/minimal. And like MVC or WebAPI, we can take in parameters. So let's take in 2 parameters here. And then in our method, we can say int1 and string2. And now when we return a message, perhaps we want to return something like this. And so we'll say our message is 2. and our ID is 1. That's pretty cool. So now it's going to come in, these parameters will come in off our post body by default and map into place. But if it finds it in the, oh, actually these come off the route. And so we'll be able to grab interesting things. So now what if we want to take additional actions? So act.map put, and we'll go to /API/minimal. And now I want to grab the object body, and there's nothing magic about this name here. It's just I want to grab that piece, and then I want to take some action. So maybe I'm going to save to the database, and then if it worked, I want to return results.ok. Now, previously we would reach into extension methods on our controller to say, did it work? Now, we don't have a controller, so we have this static results class that allows us to do really interesting things. So we could also say results.created, and now it gives us a 201. Or we could say, I want to say else return results.notfound. Or I might want to say results.statuscode of 404 or 500, and I can definitely do that as well. So this results class is a really elegant way to be able to keep track of, be able to return specific status codes together with objects. Now in this case, we're just returning an object, but here we're returning status codes as well. I think it wants me, oh, it's saying that's not set, or that's not changeable. But that worked out well. We were able to integrate minimal APIs into the same mechanism where we have web APIs and MVC and Razor pages. Now, in time, we might say, that's kind of a lot of stuff to be right here in program.cs. So I'm going to do something interesting. Let's, I'll create a new folder, and I'll just happen to call it APIs. And let's add a new class in here. I'll call this minimal, and we'll see if we can add a little bit more structure to this project. Now I'll use the new C# 10 namespaces there. There we go. And then let's see if we can go grab this map content and move it out of this spot and maybe give it a little bit more structure. So let's come in here and paste some content. So I'll create this get method, public void get. And this get method will go like that. It actually doesn't return void, it returns a message. So let's come in models and we'll create a new class called message. And this will have a public int ID, that's great. Public string message, that looks good. And public message data. And now we can do some, oh, this wants it to be nullable or set on the way in, so that looks good. Oh, let's call this minimal model instead of message. That'll be a little bit better. Rename, there we go. So back here into our minimal piece, let's return this minimal model. So we'll create a new minimal model and let's make that capital. So that's our get method. Let's do a public minimal model put, or post rather. And so we'll go grab this method that is our post, set that in place. Now we'll return a new minimal model here as well. Here's our message and here's our ID. And let's do public, oh, there we go. Public results. I think it's actually iResult. Let's come back to that. Put, and we'll do our method here. There we go. And now we've got this results.ok. Is it a results? It is an iResult. There we go. So now we've got these methods spelled out. So now let's see if we can call them. Maybe I'll have a public void initialize method. And here in initialize, I might take in an app. Web application app. Or I could even say this is a program, but I kind of like web application. Then I'll say app.mapGet. I'm going to map get to my get method and post to my post method and put to my put method. And now we've kind of rigged this up. Now that did add a bit of structure to our minimal API, but if we look at this, it pretty much looks like a controller. I would argue that this is probably the spot where we want to flip over and use WebAPI instead of minimal APIs. Oh, we also need to rig this up in here. So let's say we could say minimal equals new minimal and minimal, initialize, passing in app, but it looks like we're going to need another global using. So let's come in here and we'll say global using site.apis. And now we've got program.cs built up, but we've also got dependency injection. So let's say var min equals app.services.get required service of type minimal. And now that will yank it out of dependency injection in the same way that we did everything else with dependency injection. We can yank it out of dependency injection, we can initialize it, and away we go. This is probably not a great use case for minimal APIs, though. We've got enough stuff going on in our application that it's probably better for us to upgrade that to a real controller and take advantage of some of the benefits that we have in our controller. Next up, let's take a look at testing. We'll come back to finding a better use case for minimal APIs. Now, I've been working inside this .NET5 project, and so we've upgraded it through .NET 6, namespaces, global usings, implicit usings, the new builder, minimal APIs. We added more structure. Let's take a look at testing. So here inside of our testing folder, and then we'll look at a right-sized minimal API. That'll be fun. Let's open a project. Now, I've not done a whole lot to this, but I did create a new XUnit testing project. So here's this XUnit testing project, and it does pretty much the same thing that we would do in any normal unit test. So here's a unit test where I go create a mock logger, and I inject that mock logger into this weather forecast controller, the one that we had here. Now with this weather forecast controller, I can't predict how random is going to work, but I know it's going to create 5 entries. So here in this unit test, let's go call controller.get, and we'll go expect 5 things to come out of it. Now I love this assertion scope. This is new in .NET 6 in XUnit that allows us, actually it's not new in .NET 6, it's in XUnit, and it allows us to be able to run all of the assertions, not just stop on the first failure. So if we wanted to be able to validate all the things, we can run each of these assertions and grab their results. That's really, really helpful. So that's a unit test. How do we do integration test? Now, traditionally, we've had to go find an open port, spin up a server, and fire web requests at it. But we can do something very different here in .NET 6. Now, our ASP.NET 6. This descends from Web Application Factory of program. Here's our program.cs that we built previously. We can override the create host method, injecting test services if we want to. So don't hit the actual database, but hit an in-memory database perhaps. Or don't hit the actual API, use this fake API, the testing API. Or let's override tokens or settings that we need to. In this case, we could even override what environment we're pushing it towards. Now, by default, program.cs is private. As it does this big builder.process, it's going to create a private thing. But I can say public partial class program, and because it's partial, it hooks to the other half of the program that is automatically generated and very specifically says this is public. Because it's public, now I can run tests against it. That's excellent. So we've created this instance of program, and now we can fire requests at it. So here in my weather integration test, I'm going to create a new instance of that fixture here, and then I'm going to create an HTTP client against that application. Now, the beautiful thing here is that it won't actually use HTTP. It doesn't need to launch on a particular port, but it will be able to flex my entire ASP.NET request pipeline. So authentication, authorization, any API, any middleware that needs to run to be able to pull things out of databases or validate tokens, all of that process can run without having to find a unique port. So I love the syntax. Await using, I don't need the curly braces anymore. It'll just fall out of scope when we hit exit this method. So we get the application, we get an HTTP client based on that application, and then we can fire requests at it as we would fire them from, say, Fiddler or Postman. So let's get async. We'll go to API/weather forecast, which of course will launch into this method. And we don't know what results will return, but we know that we can deserialize this into a list of weather forecast. Now, I've specifically called out with nullable reference types that we may not get one. But then here in our assertion, we can validate that we got 5 back. That's excellent. And then let's go fire up tests against our minimal API as well. Similar thing, we'll create an instance of our application, an instance of our HTTP client, and we'll fire requests at it asking for name equals test. So recall that we said hello world or hello whatever name you gave it. So we would expect it to return hello test. Now I happen to hard code 3 in this example. So, here's that 3 that we're expecting. But now I've got a test that will validate my minimal API. This is really cool. Let's come here into the Test Explorer. I can come in here to the test window and choose the Test Explorer view to be able to look at it. And it will automatically identify all the tests in my application. So let's run them. We'll run all of those tests. It'll do a build to validate that the build works successfully. And then it will kick off all of our tests and be able to validate that our tests work successfully. So it looks like our build succeeded. That is excellent. Next, let's start running our tests. We've got those 3 tests, and it looks like in our minimal API, we actually did a post test as well. So we've got 4 tests that it's going to go do. So let's fire it up. Ooh, they all succeeded, and they all succeeded really quickly. We didn't need to find an available port. We just fired our request. It did the entire request pipeline and got us the answer that we needed. Testing in .NET 6 is so easy. It is so much fun. So that was hooking up unit testing. And as you can see, the big piece about unit testing inside of ASP.NET 6 is this fixture that creates an instance of our app where we can use HTTP client to test it. That together with making program public, and we're ready to go. We're ready to test this app, to do integration testing of our application. So now we did all of this abstraction to be able to get at a mechanism where we could kind of separate pieces, and then we identified that really wasn't the best use case for minimal APIs. Instead, let's take a look at this last one, the right size, and look at what a better use case for minimal APIs might be. Now, if we have an enterprise application where we want to expose the entire database's entities together with other business logic, and we have maybe a dozen, 2 dozen, 100 methods, that's the time to use WebAPI. That service works great. But if we want to, for example, expose an interesting JSON file as a service, and that's what we'll do here. Or we just want to be able to accept a webhook, or we just want to be able to do something really simple, then we can do this. Notice that there are no other C# files other than this program.cs. Let's take a look at program.cs and see how this works. So we'll do application.createBuilder. We'll pass in any parameters that we got off the command line to be able to rig up all of our configuration details. We also have an app settings and a launch settings. Then we'll rig up our IOC container. So we're going to add the endpoints, add Swagger, add health checks. We'll come back to health checks. That'll be really fun. Then let's go grab this JSON file. Now I've done this inside of curly braces so that this JSON argument doesn't leak from the setup, and we can see how dependency injection works. So I'll read the text, I'll deserialize it into an object, assert that that object isn't blank, deserialization didn't fail, and then inject that into our IOC container. Builder.build, and now we're looking at our pipeline. So I'll put Swagger and Swagger UI only if it's development, and in production, we have standard error handling, which is perfect. And then let's map get. So if you ask for /, then we'll pull this interesting config out of dependency injection and expose it. Let's run this and see how it works. Now we've rigged up Swagger, so we'll be able to play with Swagger associated with this minimal API. And let's do exactly that. Here's our website. We hit /swagger. And we'll get straight into this. OK, so let's try it out. We'll execute this method, passing in nothing. Here's that curl command that we ran. And here's that interesting config. It gave us the correct content type headers. And it was a great way to be able to expose this configuration file through an API. Now, as part of any web service, we probably ought to have error handling and health checks. So let's see how we did that here. Now, in development, we're using the development exception page, which is the yellow screen of darn. And in production, we want to go to /error. OK, so let's handle /error, and we'll give them back results.problem. So basically a 500. And if you pass in any random URL, we want to hand back a 404 page. Now, when I first did this, I had left this off, so I thought my browser was failing me. So I'm just going to return a message that says not found so that we can see that it's actually doing that. Similarly, I want to add health checks. So I say .add health checks as I'm setting up my IOC container. And let's map the health checks to /health. So let's run this again. We have just a plain configuration file that allows us to do really interesting things when we hit the home page there. We also have error handling and not found handling, and we have health checks. So let's go to / and we get our XML page, our JSON file. That's perfect. Let's simulate an error, and we get the error details, status 500. That's perfect. Let's go to some path that doesn't exist, and we get our 404 page. Perfect. Let's hit our health check. Maybe we're running inside of a container and we want to keep track of this. And it's healthy. That was cool. This is the right size for a minimal API. All in one page, we have all of the content associated with this really small service, including, by the way, a record class that allows us to deserialize this content into a strongly typed class. We have the public partial class program, so if we wanted to write unit tests around this, we could do that as well. This is about the right size for a minimal API. If you get to maybe a half a dozen API endpoints, it might make more sense to flip over to WebAPI, where we have the full weight of all of the controllers and all of the conventions and content there. But if we have a really small piece where we just need to expose something like this, minimal APIs can be perfect. Now, as we upgraded between all of these different features, we did each one slowly. So, for example, if you're wandering through here and you just want to upgrade a .NET 5 project to a .NET 6, then you don't need to do all of this real big refactoring. You could just change that one thing from .NET 5 to .NET 6, and you can take advantage of the performance benefits of .NET 6. But if you want to take on a mechanism of refactorings, then there are lots of places that makes your C# much more terse and a lot easier to merge going forward. This has been a lot of fun getting to show you minimal APIs with .NET 6. The code is up on GitHub right now, and you can get to it really easily by going to robrich.org, click on presentations, and you can download the code. If you're watching this video later, hit me up on Twitter at @rob_rich. And for those of you here live in the event right now, what are your thoughts? What are your questions? What are places where you can use minimal APIs? One of the questions I often get is, are there any concerns about upgrading from .NET 5 to .NET 6? I've not found any. It's a pretty compatible path. If you change nothing but the moniker there in the CS_proj file, you'll see some performance benefits. Now, it's possible that you might go way off the rails and there is something that collides, but I suspect it's not likely. If you're running in containers, you can just upgrade your Docker file to pull from .NET 6 as well, and everything works out just fine. Another question I often get here is, so do I have to do all these things? Do I really have to redo my using statements and upgrade my controllers and redo my program and startup thing? No, you don't. The existing system isn't going away anytime soon. And if you don't want to upgrade your project, or you really like the separation between program and startup, then that's totally fine. You don't need to make those changes in your .NET 6 app. You can still get the performance benefits just by upgrading from .NET 5 to 6. This has been a lot of fun getting to share with you minimal APIs in .NET 6. Grab me on Twitter at rob_rich and grab this code up on GitHub from robrich.org/presentations. Thanks for coming, everyone.